In this video, we are discussing the structure of the atom. We will look into subatomic particles like protons, neutrons, electrons. We will talk about the location and the mass of each one. And we will also take a look at the mass number and atomic number for an atom. So what is an atom? An atom is the smallest particle of an element that retains the properties of an element. So remember, when we talk about properties, we're talking about chemical and physical properties. For example, let's say that you have a gold ring. You grind it up until it's dust. Well, when it's dust, each dust fragment will still have the properties of the gold ring, because the gold ring and the gold dust, they're made up of the same thing. Gold is gold. Now remember when we talked about the history of the development of the atom, Democritus and Dalton said that the atom is the smallest particle, period. That there is nothing smaller than the atom. But is that true? No, because with the help of Thomson and Rutherford and other scientists, we now know that there are subatomic particles. So what are subatomic particles? Particles that are smaller than the atom. Those are protons, neutrons, and electrons. Protons, neutrons, and electrons are smaller than the atom. Remember, Rutherford discovered the proton with the gold foil experiment, and Thomson discovered the electrons with his cathode ray tube. So let's talk a little bit about protons, neutrons, and electrons, and go ahead and fill this out on your notes. Protons, the symbol for protons is P with the plus sign, lowercase p with the plus sign. It's located in the nucleus. It has a positive charge, and its mass is 1. Neutrons are represented by N with a 0 superscript, also located in the nucleus. Neutrons are neutral, so it has no charge, and the mass is again 1. And when we talk about mass, the mass that we're talking about is AMU, atomic mass unit, which we'll cover in the next video. Electrons are outside of the nucleus, and electrons are negative, and electrons have a really small mass, and so we say that electrons basically have no mass. It's negligible. So where does the mass of an atom come from? It really comes from the protons and the neutrons, okay? So that's why we say that the nucleus is dense. The nucleus is dense, and the nucleus is positive. The outside of the atom, that is negative. So on our periodic tables, every element looks like this, or every element box looks something like this. We have the element symbol in the middle. In the top left corner, we have the average atomic mass, so the mass of the element. We have the atomic number beneath the symbol, and we have the element name. Each element contains a unique positive charge in the nucleus. So each element has their own unique number of protons, and the protons tell you the identity of that atom. Okay, so if you change the number of protons, guess what you're changing? You're changing the identity of the atom. So if you have 1 proton, you have hydrogen. But if the protons change to 2, well, what do you have? You have helium. Okay, so each element has its own unique number of protons. The protons tell you the identity of the atom. So the atomic number is equal to the number of protons. So if you look at the atomic number, you know how many protons you have. In a neutral atom, the number of protons is equal to the number of electrons. So again, in a neutral atom, the protons and electrons equal each other, right? Because think about it, neutral means no charge. So if protons are positive and electrons are negative, and we're talking about a neutral, no charge atom, then protons and electrons have to equal each other. Now, but the atomic number does not tell you the number of electrons. So be careful when you do some of these problems, okay? And the reason why is because the number of electrons could change, and we'll again cover that in a future video. But if the number of electrons change, the atomic number still doesn't change. Why? Because the atomic number is determined by the number of protons. Okay, so the atomic number tells you the number of protons. The number of protons can tell you the number of electrons in a neutral atom, but the atomic number does not tell you the number of electrons. Now the mass of an atom comes from the mass of the protons plus the mass of the neutrons plus the mass of the electrons. But remember where the bulk of the mass is? The mass is basically the protons and the neutrons, because the electrons, it's negligible mass, meaning we can say that it has no mass. So the mass of an atom, which we will call the mass number, is equal to the number of protons plus the number of neutrons. Now, the difference between the mass number and here, the average atomic mass, is that 1 is a decimal and the mass number will be a whole number, and we will discuss the average atomic mass in a future video. So the mass number again is equal to number of protons plus number of neutrons. You can also change that around so that we can figure out the number of neutrons, which is the mass number minus the number of protons. Remember what tells you the number of protons? It's the atomic number. Now let's do some practice problems. Go ahead and take out your periodic table, or you can find a copy on Google Classroom, or again, you can simply Google a periodic table. And let's find boron. So on our periodic table, boron is right here, number 5. So boron's atomic number is 5. The example gave us the mass number, which is 11. Okay, so let's figure out the number of protons. Well, how do we figure out protons? Remember, the atomic number tells us the number of protons. So therefore, it has 5 protons. Remember that if it has 5 protons, a neutral atom, and this one is neutral, if it has 5 protons, then what other information do we know? We know the electrons. So 5 protons is equal to 5 electrons. And how do we figure out the neutrons? Well, protons plus neutrons is equal to the mass number, right? So we can look at it as mass number minus the protons will give us the neutrons. So 11 minus 5 is equal to 6. Let's do our next practice problem. We have the atomic number and we have the mass number. Well, which number should we look at for our periodic table? We need to look at atomic number 17. Remember, the atomic number tells us the identity of the element or the atom. So on our periodic table, we find number 17. We get to number 17 and there's chlorine. So our element is chlorine. Remember, if we have our atomic number, we also have our protons, 17. If we have our protons, we have our electrons, 17. Mass number minus protons is equal to 18. Let's do our last problem. Aluminum. Let's find aluminum. Aluminum is number 13. So aluminum is atomic number 13. If we know the atomic number, we know the number of protons, 13. We know the number of protons, then we know the number of electrons, 13. And now how do we get the mass number? It's 13 plus 14, protons plus neutrons, is equal to 27. Okay? So for the mass number, we're not looking at our periodic table. We are not looking at this decimal number here. That is something completely different, which we will cover in the next video. Do not look at this decimal number and just simply round up, because again, they're not the same thing. So how do you figure out mass number? If it's not given to you, again, the mass number is protons plus neutrons. And that's it for the atomic structure.